Here's integrated 3. This is coming from problem 3-6, which is not a homework problem. But we were doing this in class today, so I just wanted to make it really clear what you were supposed to get out of our lesson. What we were talking about, they were calling it Graciella's method because the story problem had Graciella figuring out this method. And she was doing this thing where she was drawing a box for what's in the parentheses. And I think maybe what the problem is that the box is what's throwing everybody off. So I'm going to just do a straight up substitution, and I'm not going to use the letter X because we already have X's. I'm going to use the letter A. I'm going to say that A is equal to what's in these parentheses or what's in these boxes. Okay, I'm going to write that up here so I don't lose it. And then I'm going to go ahead and everywhere where I see this little 1/2 x plus 7, I'm going to go ahead and insert an A in there, like substitution. So this whole thing inside the parentheses, I'm just going to call it A. So I end up with A squared. And then whatever is in this parentheses, I'm just going to call it A. This is just a nice method for some fancy factoring that you can do. Now you can go ahead and do your diamond problem on this. It has to multiply to make 12 and add to make 7. So 3 times 4 makes 12 and adds to 7. So this will be A plus 3, A plus 4. And you can put it in the little area model box if you like to put it in the area model box. You'll find out that you'll get these as the factors. You know how to factor. And then zero product property, this one's going to end up being A plus 3 equals 0, so A equals negative 3. This one's going to give me A equals negative 4. I'll put those in little bubbles. Now, those aren't the answers to the original. This is the original equation right here. Those aren't the answers to this. Those, I can get the answers if I plug those A's in right here. And then I plug whatever I get from this. Well, then I could plug it in and see, you know, if it really is, I can check my answer. But so really I'm going to find out what X is by plugging the A's in here. So I'm going to grab this thing. I'm going to write it down like this. It says A is equal to 1/2 x plus 7. Well, I have two different A's, so I'll do them one at a time. First, I'll do the negative 3. Oh, okay, so I guess I could subtract 7 on both sides. And I multiply both sides by 2, and I think I'm going to get X equals negative 20. Okay, but I have to do it again. So we did this one. Now we're going to do this one. It says that A is equal to 1/2 x plus 7. That's what this says right here. We did that on purpose. We set this factor equal to A. We gave it a name. We called it A. So now I'm trying to go back and undo what I did. So I found out that A was either negative 3, I already did that work over here, or negative 4. I'm going to plug the negative 4 in right here. Okay, so I have to do it twice because there's two A's for me to plug in right here. This is negative 11. If I multiply both sides by 2, I get X equals negative 22. So there's two answers. These are the two answers to this original equation. I know that doesn't seem like it makes perfect sense, but it's better than the alternative. The alternative would be to square this whole thing out and then to distribute this 7, and then to combine like terms, and then to eventually, you'd probably have to clear some fractions, and then you would have to factor it. So this is, believe it or not, a shortcut to solving that one.